Welcome to the EMS Edge. This is the place for real talk, sharpening our skills, and staying on top of our game as providers. So if you're interested in learning, improving, and not just going through the motions, then please support this channel by liking and subscribing. Pharmacology and med math is hard, so level up your study game with paramedic flashcards. Follow the link in the comments below and use the coupon code the EMS Edge for 10% off. Okay, so down here at micrograms, these are smaller units, and then a kilogram would be a larger unit. Okay, and it's moving 3 decimal places from each one. So for example, from grams to milligrams is 1, 2, 3 decimal places. If you were going from grams to micrograms, it would be 6 decimal places. So for example, say you had 2 grams, and we need to convert that into how many micrograms make up 2 grams. Well, we would move the decimal place. So I'm going to come down here and I'm going to write it, and I'm going to write the decimal place. So 2 grams is the same as saying 2.0 grams. Now to move the decimal place, 1, 2, 3, 4, 5, 6. So the new decimal place goes there, and then you fill in the zeros, and you can see that this is 2 million. 2, 3, 4, 5, 6. So it would be 2 million micrograms makes up 2 grams. So say that we change the problem a little bit and say instead of converting it to micrograms, we needed to know how many milligrams are in 2 grams. Well, come down here, we'll write it again, 2.0. 3 decimal places, remember from grams to milligrams is 3 decimal places. 1, 2, 3, and 2,000 milligrams is equal to 2 grams. And this works vice versa too. If you had a problem that asked you, you have 1,600 micrograms, and we need to know how many milligrams are in 1,600 micrograms. Well, 1,600 micrograms is the same as writing it as 1,600.0. Move our decimal place 1, 2, 3 places to the left, and we get 1.6 milligrams. And we know that 1.6 milligrams is correct because a milligram is a larger unit of measurement compared to micrograms. So that means that my number here should be smaller than the microgram number. Okay? And that's how you can quickly convert your mass units from micrograms, milligrams to grams, and back and forth. And that's our most common conversion that we do in the field. Now, we may also do this in certain cases with volume. So let me erase this here. The main volume units that we use in pre-hospital medicine generally are the liter and the milliliter. And it's the same thing. From a liter to a millimeter is 3 decimal places to the right. So if I have 5 liters and I need to know how many milliliters are in 5 liters, 1, 2, 3, that's 5,000 milliliters. The next section of our MedMath crash course is how to convert from pounds to kilograms and kilograms to pounds. To move from pounds to kilograms, you simply divide the pounds by 2.2 to get your answer in kilograms. To go from kilograms to pounds, all you have to do is multiply your kilograms by 2.2. Now, with a calculator, that math can be done very quickly and very easily. However, you may not always have a calculator, so it's good to know a couple tricks here. So say that we have a patient that is 100 pounds. So we have a 100-pound patient, and we need to know how many kilograms this patient weighs. Well, the way to figure that out, just from the trick method here, is to take 100 and divide that by 2. So 100 divided by 2 it's going to give me 50. All right, and then I'm going to take 10% of 50. Now the easiest way to figure that out with a whole number like this, it's easy, but we know that the decimal place sits right here, so it's the same as saying 50.0. If I move that decimal place 0.1, or basically move it one place to the left, that's 10% right there. That's a tenth. So now that 50 becomes 5. So knowing that I have moved the decimal place once, I'm then going to take 50 and I'm going to subtract 10%, which is 5, and I get 45 kilograms. So the cheat to go from pounds to kilograms is to divide by 2 and subtract 10%. Times that by 2, I'm going to get 90. So 45 times 2 equals 90. So now that I have 90, I now have, instead of subtracting 10%, I'm going to add 10%. So same thing, decimal place is going to move over 1. So 10% of 90 is 9. So it becomes 90 plus 9. And my answer is 99 pounds. If we were to do this in a calculator, we would get 99 and additional numbers after the decimal place. That would most likely just round up to 100. All right, that's our quick crash course down and dirty for determining a patient's weight in kilograms and weight in pounds. If you're going from pounds to kilograms, divide by 2 and then subtract by 10%. If you're going from kilograms to pounds, it is multiply by 2 and add 10%. So the single dose formula is to determine how many mLs to draw up. Now that could be determining how many mLs to draw up to administer via an IV bolus to a patient, or how many mLs you need to draw up out of a vial into a syringe to push into a bag of fluid to set up a medication infusion. This might be the first step to figuring out your drip rate, is simply putting the medication into a bag of IV fluid. So we'll start and say that we have a vial of medication here, and this medication is packaged in 100 milligrams in 10 milliliters. Okay, so this is that drug's concentration. That drug's concentration is 100 milligrams, which is a mass unit that is basically mixed in like you would mix a drink packet into a bottle of water. 100 milligrams in 10 mLs. And that analogy is basically what's happening here. If you think about it, when we give a medication via somebody's IV or intramuscularly, it has to be in a liquid form, because I can't draw up powder, which would be milligrams. I can't draw up milligrams as a powder form and give that parenterally. That would be giving a pill to a patient if it was in its mass unit form. I always recommend to begin by converting that down to determine how much of that drug is in 1 milliliter or in 1 unit volume unit. So for example, 100 milligrams in 10 mLs. The way to determine that is to simply divide 100 divided by 10. So what would happen is the 10 would come out, the 100 would go in, and we know that that's easy math. We're going to end up with an answer of 10, which means that the drug concentration here is 10 milligrams in 1 milliliter. And most of the time, we don't have to write this 1 because we know that there's just an imaginary 1 in front of that. Okay, that looks like micrograms. Don't want to confuse you here. This is 10 milligrams in 1 milliliter. All right. So we've converted that down now. So now let's say this same drug here, we need to administer 75 milligrams. That's my desired dose that I need to administer. So because I started by just go ahead and converting it down, then I can very quickly look at 75 milligrams and say, okay, well, I know that I at least need to draw up 7 milliliters. If I draw up 8 milliliters, I'm at 80 milligrams, and that's too much. And just by the way this works out, I know that 5 is going to be right in the middle of 10. So, and because it's 10 milligrams in 1 mLs, that's going to allow me to say that this is going to be 7.5 milliliters, right? And that's the answer that I would draw up. So when I draw this 7.5 milliliters up into a syringe of medication, inside that syringe is 75 milligrams in 7.5 milliliters of fluid. And so let's change the medicine and say this medicine is 40 milligrams in 20 milliliters. Okay. Well, like I said, first step is to convert that down, figure out how much drug is in 1 milliliter. So I'm going to take the 20 is going to come out, 40 will go in, and that is going to give me a drug concentration of 2 milligrams per 1 milliliter. Perfect. So I have my drug concentration. I can really start in this problem now. The formula to figure this out algebraically is to take your desired dose, so the dose that you intend to give, divide that by what you have on hand in your mass units, so grams, milligrams, micrograms, whatever the medicine's packaged in, times that by the volume that you have on hand, so liters, milliliters, etc. So in this syringe here, it's set up in milligrams and in milliliters. So my formula is, say that my desired dose that I want to administer is a desired dose. I need to give 10.25 milligrams of this medication. So that is my desired dose. So I'm going to take 10.25, put that here. That's going to get divided by 2. And the reason it's divided by 2 is because I did this first step here and went ahead and converted it down. And what this allows me to do is it allows me to simplify some of my math. So 2 milligrams, and then because I converted it down to 1 milliliter, I just have to times it by 1 to get my answer, because anything times 1 is itself. So I only have to divide once. So what we do is 2 is going to come out, 10.25 will go in. So if you were to go through and do the long division for 10.25 divided by 2, you're going to get an answer of 5.125. Okay, that times 1 is itself, so that means the milliliter is going to come here. So my desired dose in milliliters is I need to draw up 5.125 milliliters to give 10.25 milligrams. Fluid over time. This is the medication math formula that I'm going to use to figure out drops per minute over a specific amount of time. So say, for example, we have a trauma patient and we want to give this patient a medication called TXA, right, to help prevent clots in their body from breaking down. Well, the drug dosage for TXA is 2 grams in 100 milliliters over 10 minutes, right? So I can look at this and I can say, okay, because this drug dosage here, so this is a drug dosage here, because this drug dosage specifically tells me that I'm going to give the 2 grams in 100 mLs over 10 minutes, that tells me that at the end of that 10 minutes, all of this 100 cc's of fluid should be administered into the patient and the drug dosage is complete. And inside this vial of medication, we'll say that we have 2 grams in 10 mLs. Okay. And then to make the drug concentration, I also need to go and I need to get a bag of IV fluid. So because my drug dose is 100 mLs, I'm going to grab 100 milliliter bag of IV fluid. And typically that IV fluid that we mix with TXA is D5W, 100 milliliters. Okay, so I got my vial, I got my bag of fluid. Now I need to draw this TXA up out of the vial. So I'm gonna come in and I'm gonna attach my syringe and I'm gonna draw 10 mLs into that syringe. So now inside that syringe, there's 2 grams and 10 mLs. And I'm gonna take that syringe and it's gonna travel to the medication port, and I'm gonna put that syringe into the medication port and inject the 2 grams and 10 mLs into this IV fluid, okay? Now that I've put the medication from the vial into the bag of IV fluid, my concentration is now different. It's no longer 2 grams and 10 mLs. The concentration of my TXA now becomes 2 grams in 100 milliliters of fluid. Okay, perfect. Now, one thing that I'm not accounting for yet with this problem is I need to account for my drop factor, or the drip set that I use. Now with something like fluid over time, you can really use any drip set that you have. Down here in the bottom left, I'll write them. So your drip sets typically come in a 10, 15, 20, and 60 drop per milliliter set. With something like this, a 10 drop set is probably easiest, and you'll see why, because it makes the math just a little bit easier. So I'm going to take my drip set now. Now, because this medication is fluid over time over 10 minutes, I have a pretty specific formula that I can use to make this math work pretty easily every single time. And that formula is my desired dose times my drip set divided by the time. Right. So I can look at this formula and say, okay, well, what is my desired dose? Is my desired dose 2 grams or is it 100 mLs? Well, the answer is both, but in terms of my formula, my desired dose for fluid over time is 100 mLs. Because at the end of that 10 minutes, all 100 mLs has to be administered. So to figure out my drops per minute, I need to take 100 mLs, which is what I have here, times that by the drop set, and we're going to say that we use a 10 drop set, times that by my 10 drop set, and then I'm going to divide that by the time, which in this case is 10 minutes, and divide that by 10 minutes, and we would get our answer. So we would get 100 times 10 is 1,000. 1,000 divided by 10 equals 100 drops per minute. And that is my answer. That's my drop rate that I would do. So if I was to give TXA to this patient at 100 drops a minute in 10 minutes, all 100 mLs of that fluid will be administered and my drug dose is complete. Answer here is 100 drops per minute. And there may be some cases where we don't want to keep it at 100 drops per minute, because in the field it's going to be a little difficult for us to sit there and count 100 drops in 1 minute. And there's a couple different things I can do. I can divide that by 60 and I would get 1.6 repeating drops a second. Okay, so it's about 2 drops a second. That's kind of doable. I can take that 100 and I can divide that by 10. If I divide 100 by 10, I get 10. That would mean that I would give 10 drops every 6 seconds, right? I can take that 100 and I can divide that by 20 and I get 5. That would mean I would give 5 drops every 3 seconds. A medication infusion is going to be used when I need to give a specific amount of a medication continuously. Okay? So that would be an example of saying that we want to give a medication at 2 micrograms per minute, right? Now this is different than saying 2 micrograms in 100 mLs over 10 minutes. This is saying that for every minute that passes, 2 micrograms of that drug should be infused into the patient. So this infusion could go on for quite a long time. There's no specific time limit for us to stop this infusion because we need to maintain this same rate of infusion, 2 micrograms per minute, as long as I need to give this medication. And the way that I figure that out is there's a formula for that, believe it or not. That formula is going to be my desired dose, okay, times my drop set divided by my drug concentration. So if you'll notice, now that I have a specific amount of a medication, my drug concentration is extremely important because there's no specific time for me to put down here, which is how I know this is not a fluid over time question. This is a infusion medication question. Now, I would also like to note that anytime you're giving a medication infusion, it's best practice to always use a 60 drop set. Okay, that's because you're able to control the specific amount of each drop easier that way. Now, if for some reason you use a 10, 15, 20 drop set, you have to make sure that your math accounts for it because your answer will be different. So let's jump right into this. With most of our medications infusions, we have to make the drug. So this infusion I have here on the screen for you is we're going to say this is an epinephrine infusion. So what I have to do is I have to take the epinephrine and I have to pull it up out of a vial. So the epi 1:1 comes packaged as 1 milligram in 1 milliliter. Right? Well, I have to make this drug concentration, so I need to put that into a bag of IV fluid. So I'm going to take and I'm going to draw up the 1 milligram of epi. I'm going to draw that up into my syringe here. And then I'm going to need to grab a bag of IV fluid. And the size of the IV bag fluid just depends on your specific use and maybe even your protocols. As long as I account for it with my drug concentration, then I can find the right answer. So we'll say for this problem here, I didn't want to give a whole lot of fluid. So I grab a 250 ml bag of normal saline. We would always want to mix epinephrine with normal saline. And I'm going to inject that 1 milligram, 1 ml into my 250 ml bag of fluid. So the drug concentration of my medication now becomes 1 milligram in 250 mLs. Okay, well, one thing I hope you noticed right off the bat is that my drug concentration is in milligrams, but my desired dose is in micrograms. For this equation to work, I want to make sure that my desired dose and my drug concentration, the mass units, I want to make sure that they match. So what I'm going to do is I'm going to come around and I'm going to convert this 1 milligram into micrograms to make it match. So that's going to be 1,000 micrograms in 250 mLs. Okay. Now, if you remember what I told you earlier in this lesson, anytime you have a drug concentration, the best place to start is to convert that down to how much drug is in a single unit of volume. In this case, it's milliliters. So I'm going to take and I'm going to divide 250 divided by 1,000. Now that's pretty easy because I know that 250 is going to go into 1,000 4 times. So my answer becomes 4 micrograms per milliliter. This is my drug concentration that I have to use in the bottom of this formula. If I was to try to leave it as 100 micrograms in 250 mLs and plug it into the formula here, you're going to find you're going to get an error because you can't have a number You can't divide and divide like that at the same time. It just doesn't work. So I have to do this first. Now that I've got my drug concentration converted all the way down, I know my desired dose is 2 micrograms per minute. I know that I have a 60 drop set. I can plug my math in and get my answer. So I'm going to take 2 micrograms times that by my drop set, which is a 60 drop set. That's going to get divided by my drug concentration, which is 4 micrograms per milliliter, and then I'm do my math. 60 times 2 is 120 divided by 4. That's the same as saying this right here. So I know that 4 goes into 120 30 times. So my answer, I'm going to write it down here so we can see it. So 4 divided by 120 is 30. My answer is 30 drops per minute. The drug is weight-based. Now, I'm not going to do the whole problem, but say you had a drug that wanted you to give 2 milligrams per kilogram per minute, okay? And you had a patient that weighed 100 kilograms. Okay, well, the first step is you need to figure out how much drug you need to give per minute. So you're going to take 2 milligrams and you're going to times that by 100. And that's going to give you 200 milligrams per minute as your desired dose. And that's what's going to go into your formula is 200 milligrams times your drop set, which for an infusion is always a 60 drop set. All right. And then you just account for your drug concentration and the amount of drug per milliliter. So we'll just kind of give a random answer here and say that we put the medicine into a bag of fluid, converted it down, and we have a drug that's concentrated in 10 milligrams per 1 milliliter. If you're looking for a great audio-visual learning system that has unforgettable stories and characters to help you remember exactly what you need to know for complex paramedic and nursing school concepts, Picmonic may just be the thing for you. Picmonic has research proven to increase your long-term memory by 331% and can increase your test scores by up to 50%. You can follow the link on the screen, enjoy 20% off. Picmonic also comes with a free trial for 5 days. Picmonic is available for Apple products and Android products, and even has a feature where you can create your own characters and stories to help you remember the concepts that you're studying.